Hello, dear students. Welcome to the Quantum Guru. Let's see this question from IIT-JEE Advanced 2018 from Geometrical Optics. So, as you can see this question was debated by many experts. Why this was debated? First, let's read the question. So here there is, as you can see, there is a concave mirror of magnitude of focal length f. In front of this concave mirror, there is a right angle triangular shape object placed as shown, and we have to find the shape of the image of the bent wire, and the shape of the image are given in the option A, B, C, D. We have to tell which of these option is correct, and it's written these figures are not to scale. So why this question was debated? So there is valid reason for this question to be debated. Number one, that whatever we study, whatever results we have, mirror formula, magnification formula, those formula are for the paraxial rays. Paraxial rays are those rays whose angle of incidence is very close to zero. And if the rays is marginal, mean those rays which have a angle of incidence quite large. For those rays, a spherical mirror can have an infinite foci. In fact, some of the foci can be at the pole itself. So for the marginal rays, a spherical mirror can have infinite foci. And what is the implication of infinite foci? Implication of the infinite foci is that the image form will be blurred. It will not be clear image. And that is a defect of the spherical mirror. That defect is called a spherical aberration. But here in the question, if we think that this question is correct, if we see that the four option that is given, there are clear images given. So it means the questioner wants us to treat this question as a treat in this question paraxial approximation, because if we will follow the marginal rays, obviously the image will form will not be a unique image, clear image. So we will, if we want to give answer to this question, we will have to use the paraxial approximation. And with the paraxial approximation, this question become very straightforward. Let's see how we can get this figure. So this is the figure. So one way is to get the shape of the image by the ray diagram, and we can do by equation also. So the triangular shape object, I can label it as a ABC, and for each point there will be a unique image. Unique image mean there is no aberration. So first of all, I want to find the image of I want to take the all points on the line AC, and for them I will take one single ray. So one single ray that I'm going to take is going along line C itself and falling on the mirror. And notice that this ray is coming from focus and falling into the mirror. So applying paraxial approximation, this ray will become parallel to principal axis after reflection like this. So this is one of the reflected ray, and we can take any other reflected ray. Image is the intersection of reflected rays. So, and image is unique. So I can surely say that all the images, all the image of the all points on the line AC will fall on this reflected ray line, and I can just extend it here. One more result, that if the object is between pole and focus, image is virtual. So for all these points, the image will be on the back side. And I can take one more ray, and I can take one more ray from A, and I can fall ray on the pole. And this angle by symmetry, you can see that this is a midpoint. B is the midpoint of PC. This is 45 degree. This will also be 45 degree. So after reflection, the angle of reflection will also be 45 degree. So this line will be parallel to line AC, and this line AC 45 degree. So this will go like this, like this, like this, like this, and image of A will fall here, and that is the image A dash. And we know that the image of C, which is at focus, will be at infinity, and all the images of the point of line AC is on this dotted line. So the image will be like this. Image will be like this for these points. And for the AB, image will be like this. So if I want to shade the region of image, this is the object region. This is object region, and image will be the region of image would be like this. This is the image shape. And if I just want to show with the on which line the image of AC will lie, so obviously this will lie on this line, and that is plus infinity. So the y coordinate of all points of the image of points of line AC will be same. And this I can do by quantitatively. So suppose this is my y-axis as we take, and this is positive x-axis, and I can take a general point here at a distance x. If this is x, PC is f, so this distance will be how much? F minus x. This is 45 degree. So this height will also be f minus x. So coordinate of this point will be minus x comma f minus x. So for this point, let me say that this point is say m. I want to write the magnification of that point, and the formula for the magnification is fm. Fm is the focal length of the mirror, divide by fm minus u. And this fm has to be written with sign. This f here is the magnitude of the focal length. Concave mirror, so this focal length would be minus f. Here minus f, and u is the x coordinate of the object, and positive x is towards left. So x coordinate would be minus x. So minus of minus x is plus f. And we know that this m is equal to h2 by h1. h2 is the y coordinate of image, and h1 is the y coordinate of object. And the y coordinate of object h1 is f minus x. So you simplify this is minus, and you will get this h2 is equal to how much? F2 is equal to h2 is equal to f. So you can see that for any general object on line AC, the height of the image is same. So for all the points, the height is the same. So image of all points on AC will lie on the line that I've drawn like this. So this is the two ways that we have done. So in both ways, I can conclude that the final answer is answer option D. Thank you.